Welcome back students. Now we will move to the second phase of drawing graphs, that is when coefficient of x square a is negative and for different discriminants d greater than 0, d equal to 0 and less than 0. Let's start. Now here is our case fourth when a is less than 0 and discriminant d is greater than 0. Okay. Now when a is less than 0 and d is greater than 0, let's analyze this. A less than 0 means that parabola mouth in this case will be downwards. Okay. So I'll just write down like this, parabola mouth downwards, d. Now discriminant d greater than 0 means that it will cut x-axis 2 number of times. Okay. So cut x-axis 2 times. Now this will give me a rough figure. So let us draw the rough figure of our quadratic equation. This is x, this is fx. So here I will have a graph like this. Okay. Now you can easily see that it is cutting x-axis 2 times, that is representing its roots alpha and beta. This is alpha and this is beta. Now let's see what will be the minimum value. Now to talk about minimum value, you can easily see that this is going down. So that would be minus infinity. Okay. And that will occur when x is approaching. You can see that it is happening 2 times infinity or minus infinity. Okay. What is about the maximum value? We have already evaluated minimum value. The same way we have maximum value in this case, that happens at minus b upon 2a. Okay. Because here a is less than 0. So that becomes in this case maximum value and minus d upon 4a. So I will write it like my maximum value is minus d upon 4a that occurs at x equal to minus b upon 2a. Now the whole graph is divided into 3 parts, first, second and third. Okay. So to talk about signs of fx, I will talk about the regions when x is less than alpha, x equal to alpha, x lies between alpha and beta, x equal to beta and x is greater than beta. Okay. Now when x is less than alpha, you can see that this fx value is always negative. Okay. So fx is negative, it is less than 0. When x is equal to alpha, because it is a root, so fx is equal to 0. Okay. When x is lying between alpha and beta, so let's see. You can see that it is always positive. So fx is positive. Okay. When x is equal to beta, again fx is equal to 0 and x greater than beta, again negative. So we got the signs of fx. So we have positive, equal to 0 and negative, all of them. Right. So this becomes our figure. Okay. So let's move to the next case when we have discriminant d equal to 0. Now again, a less than 0 signifies that parabola mouth would be downwards and discriminant d equal to 0 means that it will cut x-axis once. So cut x-axis once. Okay. So if I want to draw the rough figure, I can quickly draw it. This becomes my x-axis and this becomes my fx. And graph would look like this. Okay. Now we have to find what will be minimum value, maximum value and the signs of fx. So let's move to the minimum value. When I am talking about minimum value, as you can see from the graph, that minimum value is minus infinity. And that occurs at 2 points when x is approaching either infinity or minus infinity. Maximum value in this case, because discriminant d is 0, so I have maximum value equal to 0. That occurs at x equal to minus b upon 2a. So I will say maximum value equal to 0 at x equal to minus b upon 2a. fx is not able to take any value which is greater than 0. Okay. Now signs of fx. So let's see in how many regions we can divide this. This is first region and this is second. So I will say that I'll take the cases when x is, suppose this is my alpha, less than alpha, x equal to alpha and x greater than alpha. When x is less than alpha, you can see that fx is always negative. So fx is negative. At x equal to alpha, because it is a root, so fx becomes equal to 0. And here x greater than alpha, again fx is negative. Okay, so this is our graph when we have a less than 0 and discriminant d equal to 0. Okay, now let's move to the last case when we have a less than 0 and discriminant d less than 0. Now a less than 0 again specifies that parabola mouth would be downwards. Discriminant d less than 0 would mean that it will not cut axis. Okay, so will not cut x axis. Okay, so now let me draw it. This is my x axis and this is my fx, and the whole graph would look like this. Okay, now again we are supposed to talk about minimum value, maximum value and signs of fx. Okay, so minimum value you can see that it is minus infinity, that is occurring at x approaches infinity or minus infinity. Maximum value occurs at x equal to minus b upon 2a and its value is minus d upon 4a. So I will have minus d upon 4a. Okay, and this is occurring at x equal to minus b upon 2a. Okay, now signs of fx. Now you can see that fx is always negative, right, because it is completely below x-axis, so it is always negative. So this gives me a very, very important conclusion for which questions, very good questions can be framed, that ax square plus bx plus c, this is the function, is always negative for all real values of x for discriminant d less than 0 and a less than 0. When these two cases are there, then the function fx will always be negative, because fx is at no time it is greater than 0. Okay, now let's solve an illustration. Let's see the question. We have to draw the graph in these 4 cases. So let's quickly draw them. Fx is always positive. So fx is always positive when it is possible when discriminant d is greater than 0, right, because parabola mouth, you can see, sorry, a is greater than 0, parabola mouth is always upwards, right. And what about discriminant? Discriminant d is less than 0 because it is not cutting x axis. Okay, it's always negative, so I will have a graph like this. When it will happen? When a is less than 0, because parabola mouth is downwards, and discriminant d is less than 0 because it is not cutting x axis. Has minimum value equal to 0. So minimum value is 0, that means graph would be like this. So here a is greater than 0 and discriminant d will be equal to 0 in this case. Why equal to 0? Because its minimum value is equal to 0 and minimum value is minus d upon 4a. So that means d would be equal to 0. Maximum value equal to 0, so graph would look like this, and this happens when a is less than 0 and d equal to 0. So we have seen the conditions and the graphs also. Okay. So students, now I hope you can draw graphs for quadratic expression very easily. You can understand that whether your mouth of parabola is downwards or upwards, what is the sign of fx throughout the interval, what is minimum and maximum value. But have you ever thought what is the application of this graphical representation? So for this, stay tuned with me. Have a great day. Thank you.